Hello, my name is Ruslan. I'm head of Advanced Security Department at GMO Cybersecurity, mainly doing penetration tests and red teaming by main job, and doing research and bug bounty in free time. Yeah, I'm in security for about 10 years. So today's agenda will be it's how we, like penetration testers or red teamers, doing our penetration tests, how we bypassing like antivirus or EDR solutions in the network. Especially it is get in touch when we speak about the zero trust client solutions where the client's tablet or Windows machine or Mac machine is considered like a secure solution, and all traffic of this machine is being monitored, and our using of our tools for penetration tests can be cut out and being monitored, and we can be detected by these solutions. So we are often faced in the need to trying to hijack or simply duplicate the VPN session of the machine, of the client machine that we have a code execution on. So we will be talking about not like hacking the VPN solutions from the outside of the world where the client need to connect them, but about how can we steal the session or config from the client machine when we are already inside this machine. So we can duplicate it to our machine and establish the simultaneous connection or different connection to the client's company's network. That will give our way to bypass these all solutions that is installed on the client's machine. Yeah. So today I will talk about the following solutions: the ZSCALER LTE-X. I think it's like a small Japanese solution. L2TP PPTP solution that is like a default in the Windows and other machines. WIREGUARD, OPENVPN. Also, we have many research in the Cisco AnyConnect, in FortiGate, and other solutions, but they will be out of scope of this talk. Yeah. So let me start with the ZSCALER. ZSCALER is like a very, very interesting and like modern solution for the VPN, or I like to tell it's not like VPN solution as we know the VPN solutions. It's like creating the tunnel and making things, but it's like a proxy. Yeah, it will create the tunnel to the client's infrastructure, but it will use like cloud solutions and the on-premise application solutions to create these connections, and it have a very, very good role-based, I think, access type. So you can tell what client can access what port on what server, or what URL can be accessed by what client. So it is very, very smart thing. So they have two things, like private access and internet access. Yeah, the private access is the access that you have to your internal company's network. And the internet security, it's like a gateway access that gives you way to put your all traffic through their servers to be transparent, so they can decrypt the SSL connection and scan it for viruses and things like that. Yeah. So how can we attack the ZSCALER solution? They have many ways, but I will introduce the two of them. Architecturally, before the version 3.1.0, that was I think 2 years ago, we found that it was executing like that. So there was a ZSA tray process in the user land, and it was loading the ZSA OS DLL into him. And what he's doing is it was using the ZSA OS DLL to calculate the kind, type, things that will include the battery, HDD, CPU ID, and BIOS of this machine. And it will use it like a decryption key for its own config that was stored in the C program data file, program data ZSCALER. But it was protected only by the crypt protect data, that is the Windows API of the DP API framework. And most worse, it was using the current user session. So any attacker that have execution under the user rights on his computer can use the crypt unprotected data on this data by providing the calculated numbers and strings of this battery, HDD, and CPU identifiers, and get the config decrypted and steal it. Why the config for the ZSCALER is important? It is a very interesting thing that we found that the ZSCALER, after the reboot of the computer, will start the VPN connection like automatically from the box. So the config must have the something inside of it that will give him this like way to do that. So we found out that there was SAML data inside it, that is config. So this SAML data will, SAML response data will have the expiration period for about, I think, 1 week that can be like reused. But from the architecture 3.1.0, they have like made some changes into their architecture. And now the user session only have the ZSA tray exe process that will communicate with the ZSA tray manager process by RPC. And the ZSA tray manager process now will calculate all these IDs. What have changed? To do the same attack, we will now need to gain the system privileges on this computer. So yeah, it became some difficult. It gave us some difficulties, but not so much, because you can like anytime get the system on the computer by anyhow tools. So yeah, how the decryption is done. Inside of the ZSA tray binary, before the version 3.1.0, there was the crypt unprotected data that will have the config file and the entropy. The entropy will be these calculations of the hardware ID, CPU, HDD, several numbers. So we just easily can decompile and recreate these calculations that was done in the DLL, or we just can like load this DLL into our process and just ask the DLL to calculate them for us. That is the simplest way. And yeah, that is the way how we've done this in the past. We just like loaded this DLL into our process, and then using this entropy data that was calculated by this DLL, we just like asked the process to decrypt this config for us. Then we just can get this config, put in our PC, in the attacker's PC, crypt it, and use as a simultaneous session into the ZSCALER. That was before the 3.1.0. After that, you just need to privilege escalate to system and recreate this attack from zero. We have reported to ZSCALER about that, but they just tell nothing. So, okay, we can tell about this. The main problem there is that they have this all like kind of checking the IDs of HDD and other stuff, and they created this entropy data. They have the SAML that used to like reconnect to their server, and the main problem that you can like connect two different PCs from two different IPs with this all like same IDs if you can calculate it. So yeah, that will be the first problem, I think. Honestly, there will be one more simple way to hijack the session of the ZSCALER. And I will like briefly tell about that. The ZSCALER like authenticates into its VPN client, usually using the SSO, and usually it is like Okta or Azure or, for example, OneLogin. So the simplest way to hijack the session of the ZSCALER will be like getting this IDP's cookie. So if you can get the IDP's cookie, you can like give it to the ZSCALER and just like do the onboarding process to the ZSCALER VPN by yourself. Yeah, I will not show it, but yeah, you can try to do. And the second one is the LTE-X. I have seen it only for once in my life. I don't know where it is used, how it is used, but it's like a product using the LTE over IP or virtual LTE model. So when you have, I think that they have a like application or solution where you can put the hardware SIM card and it will be used it, or they just created the virtual one that you like simulating the virtual SIM card and using it like LTE over IP. Yeah. So it is like registered on the Windows host as a service and automatically connect when the device is booted. So it's like always on VPN solution. I think it was mainly created for the factories or some devices like just like factory devices or yeah, device like that. But not the devices that must be used on the client side by like usual company users. So how the configuration of the LTE-X is done? The LTE-X solution using the registry to save its all data. So there is the password, the admin password to disable it, the authentication, primary and secondary DNS servers, the authentication servers for this tool, and the VPN gateways server addresses, and everything, all of them is there. The credential information itself stored in the CRED, so it's a vault to be talked about the Windows. If we're talking about the Windows, it's like a vault where user, or in this case system, can store their credentials, but it's not safe at all because we can just like use the Mimikatz solution or other penetration testing thing, or we just can like create and like use the Windows API by ourselves and decrypt it, and it will give us the credentials in the plain text. Yeah, we will need the system privileges for this as well. And as a summary, yeah, if an attacker successfully gained access and evaluated privileges on this victim's host, he can like almost in any time obtain the authentication information and connect to this VPN gateway. There are also possibility to do the simultaneous connection, and this software will not like detect that there's two connections with the same credentials from the two places. Yeah, there is no Mac version of this, so we just not looked into that. The third solution, it will be the PPTP L2TP solution with the pre-shared key. it looks like that. I think many of you have seen it. So why is the pre-shared key? There are two types of the, some more, but almost two types of the connection types of the PPT, for the PPTP L2TP connection. It will be using the certificate or the pre-shared key. The pre-shared key is the most simplest way to do that. The certificate one, it will need the certificate agency and some solution to put this certificate on all clients, but it will be much more secure than the pre-shared key. Because in case of the PPTP or L2TP, if we know the pre-shared key and if we know just like the username and password, we can create the simultaneous connections from anywhere to the server or to the VPN gateway. Yeah. So how we can get these credentials from the Windows? The PPTP L2TP connection information are stored in this path: app data roaming, Microsoft Network connections, and Ruslan PBK. That was in the past used for the dial-up connections as well. And the authentication information. Yeah, we have the VPN, the servers, the server IP stored in this Ruslan PBK, and the authentication information will be stored in the registry, in the security policy secrets path. The pre-shared key will be stored in the Rust connection credentials, and the user path will be stored in the Rust DL param, seed, SID, and the SID of the current user that stored his credentials. How we can obtain this data? We can use the two Windows API calls, like LSA open policy and LSA retrieve private data. That will require the local admin rights, so system will need, but you can grab it by calling these two Windows API. In our company, we just using the Cobalt Strike framework, so we created many extensions, and I just created one extension for this one too. So we can list the file that Ruslan PBK. We grab the DL params, it's like ID, and phone number will be the IP where we need to connect. Then we go to the registry and list all SIDs. We get the DL param UID in the stored Rust DL params path, and we get the credentials like VPN user and password. And lastly, we can tell this extension to look for the Rust DL connection credentials and get the pre-shared key. And that's all. For the Mac will be very different with the Windows, but usually it's not so hard. No. For the Mac, it will be many hard to retrieve these PPTP connections. Because in the Mac, there is two systems where the credentials and the connection information is saved. The Mac have a system keychain and user keychain. Keychain is you can think about it like a registry, but not so simply. So telling simply is the user keychain can be accessed by the user without any credentials needed, and it's saved only in the. I don't put it. Okay, so it will be saved in the users username, library keychains, user's keychain, and any attacker or user with his privileges can access it. The keychain itself, it's encrypted with the user's password, so you will just need to leak the user password or obtain it somehow. And after that, you can decrypt the keychain and take all the data from it. In the Mac, because the PPTP L2TP connections are made by the Apple's macOS application by itself, not by any third-party applications, it will store all this information in the system keychain. The system keychain can't be accessed by the user like so simply. You can use the keychain utility to access it. It will like ask you for password and user, and can be only accessed by the GUI. So, for example, if you have the code execution on the Mac, you can use the scutil and clist to list the VPN connections. You can like show of, using the GUID of this connection, you can get the IP address to where it connects, but the actual information that is saved in the system keychain, any attacker that have only the code execution but not the interactive way to connect to touch the machine can't retrieve it, because starting the macOS Mojave, this system key that is that the file that have the key to decrypt the system keychain, it's now applied by the SIP, your system integrity protection, that will tell you that if you even have the root privileges, you can't access it. Before the Catalina, you have this, just like get the root on this device and get this string to decrypt the system keychain. Yes. And then the summary. In the Windows, L2TP, PPTP, it can be like secure, but in this case, you just need to use the client certificate or machine certificate authentication, and the certificate must be stored in the TPM or at least YubiKey, so the attacker couldn't be possible to obtain it. In the Mac, any type of the VPTP connection will be much more safe than in the Windows, because the system keychain can be accessed without disabling SIP. Yeah. So the next one is the WIREGUARD. I think it's very, very, very good thing. That is very like modern thing in our now. So how the connection is done in the WIREGUARD is like you create the profile in the server on the client, you get the public key of the server and give your your public key to the server, and the server registers you as a user, and you can just like connect with your WIREGUARD application to the server. The best part about the WIREGUARD is like it's very, very fast, almost twice or third fast than the OpenVPN, and there is almost no loss of speed on the devices like a Raspberry Pi or these small PCs. So yeah, it will look like that. Yeah, it's not so big. On the Windows, on the Mac side. So how the WIREGUARD storing his config. On the Windows, it will be stored by the DP API, like a ZSCALER, but instead of getting all this stuff like ID or BIOS ID or serial numbers, it will just like use the system account password to call the DP API and encrypt it. So we just need only get the system on this host to decrypt the config. So yeah, that will be the extension for the Cobalt Strike that I have created. So from the user's perspective, even if you have an admin, you can't touch this file because it only have the full access privileges to the system, and the administrator, even the administrator, can only delete this file, but you can access it from the GUI. And also you can, access it by getting the system privileges on the host. But getting the administrator on the host is like equal getting the system privileges. So Inside of this, it will be the DPAPI protected blob data that can be decrypted with the system privileged privileges by providing its session data to the crypt and protect data Windows API. And the config file of the WireGuard will be like that, where you have your private key, the public key of the server, the address that is assigned to your client, and the endpoint, the server's IP address. For the Mac, it is almost the same with the PPTP, but instead of saving this data to the system keychain, the WireGuard, being the third-party application, I think because of that, it stores its data to the user's keychain, and the user's keychain will be in that path. Library keychains, login keychain DB. That can be accessed, as I told, by any attacker that have code execution on the host. And by the GUI, you just can use the keychain access program, access it, open it, and decrypt it with the user's password. From the attacker's side, you can just download the keychain and guess or obtain by somehow the user's password and decrypt the keychain, and you will get this data to you. As a summary, so in the Windows side, you just need to evaluate your privileges to the system to obtain this data. The config file in the Mac, you just need like leak the user's password or obtain it by phishing or some other attack and decrypt the keychain. The good thing for the WireGuard is that even you steal the config file, you can create the simultations session to it. So you just need, like, if you establish the connection, the users will be kicked off, and other. And if he's established the session, you will be kicked off. So you just need to wait where the users get sleep, for example. Yeah. But the WireGuard is very, very good thing, the very good solution in the terms of the speed. And honestly, I personally want to use it, but it's like no way to implement the 2FA or MFA for it in the simple way. Yeah, we can like compile it by adding some authentication methods to it and recompiling it, but it will lose his cross-platform compatibility and with other clients. There is also only one, the paid solution like Tailscale, that made this 2FA, I think under or in the top of the WireGuard. Yeah, I don't use it, but it looks very, very good. And the last one will be the OpenVPN solution. It's like a freeware as a WireGuard and all others, but personally I very love the OpenVPN. It is the SSL-based OpenVPN solution. You have many variety of the implementations that it can be done. The only configuration file where you have the SSL certificate inside it and no credentials needed to connect it. So you just like give this configuration file to the OpenVPN and run it, and it will connect. The most insecure way to do it. The second one is like you can encrypt the SSL certificate, and it will like ask the user for the password anytime when you're trying to connect it. The third one, you have like a user password that you need to input enter when it will be connected, and also you can just like give it to the you can also encrypt the SSL certificate in this way. So you will need to type 2 passwords. Yeah, that will be annoying. And the last one, you can use the OTP thing, like a Google Authenticator or YubiKey, and create and use the OTP instead of the user's password. That will be not so bad, I think, and it will increase the security level of the OpenVPN. So one more level that you can increase the security, you just can store the SSL certificate that is usually stored in the configuration file to the TPM or to the YubiKey. So then the attacker can't get it that. For example, there are many cases where you can use the OTP or FIDO authentication instead. Personally, I'm not finished by creating the solution where the VPN and FIDO can be used together. That will be the much more secure way than the OTP. By now, in our team, for example, we are using the OpenVPN and YubiKey solution, the last one from this thing. Yes. And that's all. Any questions? Thank you. Okay.
Thank you for your speech. At the beginning, you said that we can establish simultaneous connection or separated connections, and WireGuard doesn't support simultaneous. So what's the difference between simultaneous and separated connections? Is there such things, or it's?
Yeah, it's not like you have two choices, not the two choices, but the two solutions, the two varieties of the connections that you can do. For example, for the PPTP or L2TP, you can establish the simultaneous solutions to the VPN using the same ID and password or the same configuration file. For example, for the WireGuard, you can do only one connection per time because it will use the private public key and create only one tunnel to them. So yeah, for the WireGuard, you need to wait where the user will disconnect his session, and then you can connect your session. In all other ways, on all other solutions, as we checked, you can do the two same connections to the server, and it will not say nothing.
Mm-hmm.
So for our perspective, we want to be able to do the simultaneous connections. So yeah.
Yeah, seems WireGuard is safer.
From this point, yes.
One more question. It's not related to VPN, more related to Cobalt Strike.
Okay.
You said extensions, you wrote extension. What is extension? Is it just a sequence of steps which be executed on owned host? So you just drop it and it will run all those commands which you showed on your slides?
Yeah, it will depend, because for the Cobalt Strike framework, there are two types of the extensions. For example, the automation that you told, it's like you want to do the ls or the folder to download file and something like that, and it will be the automation. The thing that I have done, for example, here, it will call the inline execute and something.o file. It is the object file. So this extension will look like a C program with the Windows API calls, and it will be executed inside of the memory of this process in the main thread. Yeah. So it's like
so inline execute is what?
It's like you injecting some
got it.
C code inside of your main process.
Yep, got it.
Yes.
One more question. In your slide, you showed that in Mac we cannot access some system key file.
Yes.
Even though on screenshot I can see read permission for root.
This one? Yeah.
Yes, there is clearly R for root, but why we cannot access it? Do you know why?
Yeah, because the SIP. The SIP thing is like a system integrity protection. It's like Mac solution to prevent these access types or deletions and other thing. So when this flag, or I don't know, maybe it's not flag, you have on the file, you can't access it by root or even by the root. It is like a protection.
I see. Maybe it's like ACLs on Linux, you know, outside of usual rights, you can set up some additional extra things, extra checks.
Yeah, it's look like that, but you can disable it by rebooting the Mac into the recovery mode and typing commands. So it is like a place that is protected by the kernel of the Mac, where the user can't access. But yeah, because I told that you can access the only one way that you can access to this thing by the GUI. So this keychain access program have the very strict privilege to access the system keychain only by this GUI stuff and by like entering your ID and password 2 times. So yeah, it's like a back way. So in the terms of the stealing the session, this session can be stealed by the user himself because he can access it. So yeah, the user, if he's like insider or bad guy, can steal his session to his own computer and create this connection. That will be like different model attack, not the outside attack, but the inside attack.
Mm-hmm. Got it.
Yeah. So in terms of the like, we can't 100% tell that that all access to a corporate infrastructure will be done from this computer in that way, because user by himself can take these credentials and access from other computer. Yeah. The only way that when we can speak that the user can't use other computer to access the internal network is like when your certificate inside the TPM and this certificate is used by the VPN solution to access the VPN.
And not accessible by user, but only by
Yes.
VPN solution. Yeah, got it.
So, any other questions?
I think this is the second time to see YubiKey in your presentation. I think last presentation also you showed the YubiKey. So actually I don't know the detail about the YubiKey, but I can imagine like a USB type key. So if people lose the key, what is the way of recovery? Like
What?
the recovery, how if I lose the key?
Yeah, that will be the most question.
What is the way of recovery? So I don't know the.
For example, in our infrastructure, I created 2 types of the authentication. It's like by using the YubiKey that I have also in my host. So if I will use the YubiKey, by the recovery I can use the Google OTP. But it will be used only when the recovery stage. For example, if my colleague will lose the YubiKey, I can turn for him on the Google Authenticator, and he will use his Windows application, mobile application, Google Authenticator to access the VPN.
Mobile application will help the recovery.
Yes.
Is it?
You can use the OTP that will be given you by the mobile application's Google Authenticator to access the VPN, because it will be your password.
Okay. Yeah. Thank you.
Yeah.
Okay, any other questions? Okay, since we have no other questions,
Thank you.
Thank you, Ruslan.